Good day, everyone. You're welcome to SMDexecutives Academy. So this is a video that is being requested for by one of our followers who requested for a video on motion. So this will be dealing with motion, and there is a question on the board there which we'll be solving. So the question is dealing with motion, and we have the question boldly written there on the board. So the question goes thus. It says that a car moves with an initial velocity of 25 meters per second. Okay, with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? So here, the car is moving first with an initial velocity of 25 meters per second. Then it increases its velocity to 45 meters per second. On increasing its velocity to 45 meters per second, the time it takes to increase the velocity from 25 to 45 is 10 seconds. Then what is the acceleration? So for us to calculate the acceleration goes thus. Recall that the formula for acceleration is acceleration is equals to change in velocity over time taken. Acceleration is equals to change in velocity over time taken. Then acceleration is equals to our change in velocity happens to be final velocity minus initial velocity over time taken. Now, acceleration will then be equals to what is our initial velocity first. Let's write out our data. Now, what's our first velocity? Our initial velocity is equals to 25 meters per second. Our final velocity is equals to 45 meters per second. Then our time taken to increase in velocity is 10 seconds. Then our acceleration happens to be change in velocity. That's 45 minus 25 over 10. 45 minus 25. Acceleration equals to, that gives us 20. 20 over 10. So obviously we know that our acceleration now will now be equal to 0 cancel 0. That's 2 meters per second square. So 2 meters per second square. So the acceleration for this car to increase in velocity from 25 meters per second to 45 meters per second in 10 seconds is 2 meters per second square. So we can say, using velocity time graph, our acceleration is this. This is your velocity and this is your time. So this car begins from 25 meters per second. Then let's take, for example, this is a 25 meters per second. So your velocity in meters per second and your time in seconds. Then this car increases suddenly to 45. So in increasing this car to 45 meters per second, the time it uses to increase it happens to be 10 seconds. 10 seconds. Then our acceleration, which is here, will then be equal to 10 meters per second square. That's the acceleration it took that car to accelerate, to change the velocity from 25 to 45 meters per second. So we have a lot of questions here to solve. I will write another question on the board so we quickly get that right. So this is the first question which we have dealt with. Now, we have another question here, and it says that a body accelerates uniformly from rest. A body accelerates uniformly from rest. A body accelerates uniformly from rest. A body accelerates uniformly from rest at 2 meters per second. At 2 meters per second square. Calculate. So this question is telling us to calculate its velocity after traveling a distance of, after traveling 9 meters. So this is what we want to deal with. The first thing which we need to do is to write out our data. What are the parameters which we have been given? We have been given, our data which we are given are, let's take it this way. Our data are, the first thing we are given is that a body accelerates uniformly from rest. Rest simply means that the initial velocity is equals to 0. At 2 meters per second square, then we are given acceleration to be equals to 2 meters per second square. It accelerates at 2 meters per second square. Calculate its velocity. That's the final velocity which it has attained after accelerating 2 meters per second square. After traveling a meter of what? That's a distance, 9 meters. So at this point, we're calculating our velocity, and the perfect formula to use for these data are v squared equals to u squared plus 2as. Our s is our distance, a is acceleration, and u is initial velocity. So v squared equals to, our u happens to be 0 squared plus 2 times acceleration, 2 times our distance is 9 meters. So we have v squared is equals to 0 plus 2 times 2, 4. Then 4 times 9, 36. So that gives us v squared equals to 36. Automatically we have our v squared to be, then v squared is equals to 36, right? So we take the square root of both sides. V squared, v is equals to the square root of 36. And square root of 36 is what? 6 meters per second. So that happens to be our velocity of the car when it accelerates 2 meters per second square, and it covers the distance of 9 meters from rest. Then we have this final velocity.